Welcome to PyMath. In this video, let's look at how to solve a formula that is used in higher secondary mathematics. This is widely used, associated with logarithm. Log n to the power p to the base a to the power q equal to p by q log n to the base a. You may already know the fundamentals of logarithm. Log and exponents, they actually undo each other. They are inverse of each other. So whatever logarithm does, exponent will undo it and vice versa. So let's say we get 10 to the power of 2, which is 100. This is an exponent function. And log of 100 to the base 10 is actually 2. So this is a typical example of how the exponent will behave, and log of x to the base 10 is how y is arrived at. This is a perfect example of a logarithmic function. So let's get to solve this formula. Let's equate the left-hand side to a variable and the portion of the right-hand side to a variable and see whether we can solve this formula. So understanding this formula will help you remember better, and you will appreciate and use it more often. So let's equate this left-hand side to a variable. Let's call it as y log a to the power q, n to the power p to the base a to the power q as y. And let's call the right hand side, a portion of right hand side, which is log n to the base a as z. So as you all know, a to the power q to the power y is actually n to the power p. That is a basic definition. As we saw here, this is how the logarithm is supposed to be. So a to the power n to the a to the power q to the power y will give you the n to the power p that you all know. So now let's simplify. The q and y can be multiplied, equal to n to the power p. So this is where we arrived at. Let's get to the right hand side. A to the power z will give you the n. Let's raise it to power p, because this p, the right hand side of the formula, can be essentially brought here as a power, right? So that's one of the basic formula for logarithm. So m log, let's say y to the base x is actually log y power m to the base x. This can be done, this is allowed. So I'm bringing the p here. For that, I'm raising the right hand side to p, and so has the left hand side to p. So this we arrived at by raising both sides by power p. So we got n power p on the right hand side, n power p on the left hand side. Let's equate them and see whether we can arrive to the original formula. So a qy equal to a to the power of qy equal to a to the power of zp. So, and the bases are the same, so the power has to be the same. So qy equal to zp, and the variables that we introduce is actually, remember, y and z, right? So y equal to p by q z. So this is where we arrived at. So let's equate back what was y. Y is the original left hand side of the equation, log n to the power p by log a to the base a power q equal to p by q. What is z? Z is originally a part of the right hand side equation, which is n to the base a. This is the formula that we are trying to solve or prove, and we have proved it. So let's apply this to a real problem and see whether it makes sense. So let's say log 10,000, the base 100. So we know this is 2, but let's try to use this formula which we're trying to prove. Log 10 to the power 4 to the base of 10 to the power 2 equal to, this is our P, this is our Q. So P by Q log 10 to the base 10 equal to 2 multiplied by 1 equal to 2. So thus, when we use this formula, we just verified using a simple example that it is correct. And it applies to all the other conditions too, all the other scenarios too. So that's why this is an identity, logarithmic identity that you got to remember, and it will help you in solve advanced problems. Thanks for listening.